Hey everybody, in this video we're going to be looking at all three inverse trig function values together. So this is kind of just throwing together the last three videos into one and mixing them up because each video dealt with arcsine, arccosine, and arctangent individually. Now we're just sort of putting it all together. And so I don't have any unit circle on any of these worksheets because we're assuming you've already seen them. So if you need to go see the worksheets on the other videos, links are in the description below. So let's get started. So here we want to find cosine of arcsine of 1/2. So starting from the inside, we want to know, all right, at what angle is sine 1/2? Well, let's see. Arcsine gives us any angle between -90 and 90, and the angle where sine is 1/2 is 30 degrees. So now we're asking, what is cosine at that same angle? And that answer is radical 3/2. And so that is the value of this expression. So for number 2, here we first want to figure out what is cosine of pi/3. All right, so on the unit circle I have to think, what is the x value at pi/3? And that value is 1/2. So now we're saying arcsine of 1/2. We're asking, all right, what angle is sine 1/2? Well, that's the same as that value up there. And since we started in radians, let's stay consistent. So instead of 30 degrees, we'll put 60 degrees. So for number 3, here we want to find tangent of 2 times cosine inverse of 1/2. Now remember, this is finding an angle, and the 2 out front is just going to double whatever we find. So, where is cosine 1/2? Well, cosine is 1/2 at 60 degrees. All right. Now we still have a 2 out front. And so when we multiply the 2 in, we get 120 degrees. So tangent of 120 degrees. Well, at 120 degrees, if we were to sketch that out, it's going to be right about there. And the x value is -1/2, and the y value is square root of 3/2. So if we were to divide them, we would get a value of negative radical 3. Because remember, we would take square root of 3/2, the y value, and instead of dividing by -1/2, we'd multiply by -2. So then, number 4, here we have two expressions, tan inverse of 1 and sine inverse of 1. So tan inverse of 1 is asking, when is tangent 1? Well, that value is at an angle of 45 degrees. This is asking, when is sine have a ratio of 1? What angle does that happen? And that's at 90 degrees. So we'll fill in the rest. And first, we're going to subtract those two angles. So we end up with cosine of -45 degrees. So on the unit circle, at -45 degrees, cosine is positive square root of 2/2. Now on this second page, we're not given any numbers. Instead, we're just given a value of x. And so we want to know, what is cosine of the angle when sine is 1/2? And the way we deal with this is we draw out a picture. Now the angle in question is right here. Just call it theta. Now we'll never actually figure out what the value is, but that's not important. What is important is that we're told that sine is x, or we could think of it as x/1. So the opposite side is x, the hypotenuse is 1. So if I want to find this side, I just use Pythagorean theorem. A squared plus x squared equals 1 squared. So a squared is going to equal 1 minus x squared, and so a is going to equal square root of 1 minus x squared. And so that's the picture that we have. And so what we're asking for is, what is cosine of this? And so cosine of this is this expression, square root of 1 minus x squared, all over 1. And there's no need to put the over 1 part. Doesn't change anything. Now for the second one, here again, we're given an expression. This time we're told cotangent of cosecant inverse of x. Now, at face value, it sounds a little more difficult, but wait a minute. The information is more or less the same. This is telling us that we're talking about a certain angle, this angle. And it's telling us that cosecant is x, or x over 1. Now, cosecant is just sine, but flipped upside down. So what would sine be? Well, sine would be 1 over x. So that means this side would be 1, and this side would be x. And we want to know what is cotangent of this angle. So we need this side. So we use Pythagorean theorem again. A squared plus 1 squared equals x squared. So a squared equals x squared minus 1. And so a is going to equal x squared minus 1. And so there is the length of our adjacent side. And so cotangent is, well, it's tangent upside down. And tangent would be opposite over adjacent. So cotangent is adjacent over opposite. And so we get square root of x squared minus 1. And literally it's over 1, but no need to write that. Doesn't change it. Thanks for watching. If you liked the video, give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.